A researcher is studying the relationship between eating behavior and body weight. Subjects are selected for the first IV weight based on whether they are categorized as normal or obese in terms of body mass index. Half of the subjects in each weight category are randomly assigned to one of the two levels of the second IV hunger. There were n equals 20 subjects in each condition of the study. All subjects were brought into the lab early in the morning without having eaten breakfast and asked to wait for 2 hours before the study would begin. Subjects in the low hunger condition were fed a light, healthy breakfast after they arrived. Subjects in the high hunger condition were not allowed to eat or drink anything. When the study officially started, the subjects were told that they were taking part in a taste test for several types of crackers and that they could eat as many crackers as they wanted while they were there. The dependent variable was the number of crackers eaten by each subject. The research predicts that the degree of hunger, high or low, would affect normal weight and obese subjects differently in terms of many crackers they will eat. So, the first part of the question says to list each of the different treatment conditions in the study. So, to do that, we can just draw a 2x2 box, and then we can figure out our treatment conditions from there. So draw a 2x2 box, and then at the top I'm going to put eating behavior, and then on the side is weight, and it's a little bit sloppy, but I'm sorry about that. So eating behavior, and then weight, and then in the columns I'm going to write not hungry, just abbreviate it, and then in the right column I'm going to write hungry, just abbreviate it, and then on the sides for the rows I'm going to write normal and then obese. So then we can see that our 4 conditions will consist of normal not hungry, normal hungry, obese not hungry, and then obese hungry. So those are our 4 conditions in the study. Part B says to state the null and alternative hypothesis for the effect of the independent variable 1, independent variable 2, and the interaction of the independent variables on the dependent variable. So basically, our first independent variable is weight. So the null hypothesis will say that there will be no difference in number of crackers eaten by normal weight subjects and obese weight subjects. The alternative hypothesis to weight will be that the obese subjects will eat more crackers than the subjects of normal weight. The independent variable 2 is eating behavior, and it says for the null that there will be no difference in number of crackers eaten by hungry and not hungry subjects, and the alternative is that the hungry subjects will eat more crackers than the non-hungry subjects. And the interaction, which is our weight and our eating behavior combined, the null says that there will be no difference, that no difference will be present in the number of crackers eaten across all conditions of weight and hunger. And the alternative hypothesis says that the normal weight subjects will display the predicted effects of hunger, but the obese subjects will not display a difference in number of crackers eaten across all conditions of weight and hunger. So that is our null and alternative hypothesis for each of our levels. And then part C says that given the data, we are to graph the data according to average number of crackers eaten by subjects in a particular condition. So I created a graph, and I'm just going to draw it here. So there, and then So I'm just going to do like 5, 10, 15, 20, and then 25. Not hungry, and then hungry down this way. And now we're going to graph it. Okay, so basically we take our needs that were given to us in the little chart included in the problem. We have the needs already worked out for us, so we're just going to graph based on those needs. So the first need that I'm going to graph is 15 and 18. So and then I went to actually no, that's too much. Start that over. So this is what my graph looked like here. So it's kind of sloppy, but you can basically see that we have an interaction between normal and obese subjects, and there's a little bit of a main effect present here.